Welcome to part 4. In this part, I want to talk about parsing data. When you think about the data that are in a CSV file, what do you have? You have characters that you've typed into a computer, and they've been recorded and stored in this file. So if you think about it a moment, if you store, say, a sequence of integers into a column in an Excel spreadsheet, as far as Excel knows, you've just put in a character. It doesn't know that that's a number. And then think about reading it into R. How does it know that this is actually a number? This is one of the questions that has to be addressed when we parse data. Parsing is the act of separating data into parts. So there's a lot of complicated things going on behind the scenes, even for something that looks so obvious to you, like the numbers in an Excel file. In order for our statistical programs to be able to know what are numbers, what are characters, what are dates, we have to separate the data into parts. And if you're going to be good at working with data, you need to have some sense of how to deal with some rather messy situations that we can encounter. So let's take a look at this and further explain what I'm talking about. All the data in flat files are characters. So reading a flat file into a tibble requires functions that analyze this text and separate it into parts of the correct types. The process of this separation is known as parsing. And somehow we have to be able to identify that really what we mean are for these to be numbers, not characters. So let's show you. In this case here, I have created my nums. Well, what kind of vector is that? If I look at type of my nums, that's a character vector. Now, you see that I put the quotes around it. But what I'm doing is I'm imitating what happens when we read from a CSV file. Everything in a CSV file is just a string of characters. So when I read from a CSV file, as far as we're concerned when we look at what I'm going to call the raw data, it's just characters. But now we have to recognize it as numbers. One way to do that is with parsing functions. So here is a parsing function that will take the elements of a vector and turn it into integers, and it's called parse integer. So if I now look at my .nums, I see that I have the vector that we probably intended when we put 10, 23, and 41 in our file. We now have an integer vector. Here are some more examples. Suppose we read in from our CSV file, true, false, false, NA, true. Well, from an R standpoint, you know what that means. But you've got to get your computer to see that. And so if we use the parse logical operator, then we actually can turn that into a vector of logicals. Notice the absence of the quotes indicating these are no longer characters. These are actual logical values. Here's another one in which we have characters, but these characters appear to be dates. If we parse them as dates, then we in fact get something that looks as a character. And they're shown as a double. That's because dates are stored as doubles. I'm not going to get any further into that, and we're not going to do much with dates in this class, although I have had students who have taken this class that have told me about needing to work with dates for things like data files in which people enroll in courses, and there's an enrollment date attached, and they've been able to do some pretty cool things in R with dates. We can tell the parse function what is missing data. So here I'm going to tell parse integer that the period really means missing data. So now those characters, including the period, have been turned into numbers, as you can see here. Type of is integer. And when we look at this, we see that the R expression for missing has been placed in place of the period. Parsing will fail if the type of parse doesn't align with the text. So look at this one. Here I've said, let's use the period to be missing data, and let's parse as an integer. But look what I've got. I've got a couple problems. One is that Bob is not going to be able to be turned into an integer, and another one is there's a period in 72.9. So let's try this. And I've, in fact, have two parsing failures. We are trying to make an integer out of Bob, but it's not. We're trying to make period be NA, but it has some characters in with it. Namely, the trailing 0.9 is what it identifies. When there are problems, instead of just creating a vector, the vector will be part of a tibble that also has problems attribute. This is because the cleverness of the tidyverse functions. Notice the parse functions we've been working with have that underline indicating that we're working with a tidyverse function. So what the tidyverse does in a situation like the one above, where we ended up with problems, if we look at that, we see that we have an attribute. So here are the numbers. We have Bob and 72.9 have now been turned into missing, but there's an attribute problems attached, and here the problems are stored right in with the data object. That's pretty powerful. You can capture this tibble with the problems function, and that's especially useful if you want to investigate many problems. So let me take problems, the function problems with my nums, and capture it and see what we get. We get what row it's on, what the column is now currently holding, what we had expected, and what we actually found. Have you ever been in a situation where you've hunted through data to find a problem why something didn't work? If so, you can understand the power of what we're seeing right here.